not, gentlemen, the nuclear weapon exists on both sides of the Iron Curtain. It is today a major factor in international power politics and the big stick of military strategy. Properly handled, the Army's capability for measured nuclear response is a very effective restraint against communist aggression. Warheads like this W-31 punctuate the margins of our free world. They travel through our seas, move across our skies, and weave themselves into the fabric of our major communities. During the past few years, scientists have been busy trying to perfect a weapons system known as a wooden warhead. Such a weapons system would require a minimum of care and maintenance. It could be packaged and put on the shelf like a 90-millimeter shell. Until science achieves this ideal, however, the nuclear warhead remains a very complex piece of machinery. The small Army units of highly trained men who assemble, handle, and employ these warheads must follow precisely the exacting standards prescribed in technical publications. This is equally true of combat units such as engineers, artillery, armor, and infantry. These standards are also required for ordnance support units performing higher echelon maintenance and storage operations. Everyone who works with nuclear weapons has three highly important factors to consider: safety, security, and reliability. On the one hand, these special weapons must be completely safe and secure. They must never detonate unless we want them to, since the resulting destruction, loss of life, misery, political repercussions, and enemy propaganda triumph can scarcely be exaggerated. At the same time, these weapons must be completely reliable, which means that they must be ready and able to deliver their devastating impact at the very split second it is needed. It is to assure safety, security, and reliability in handling nuclear weapons that the Department of the Army has provided for a system of technical proficiency inspections to be conducted under the overall surveillance of the Inspector General. Under this system, every nuclear weapons unit is given a technical proficiency inspection, commonly known as a TPI, by a specially trained Inspector General at least once a year. These inspections are primarily concerned with a nuclear weapon, excluding its means of conveyance or propulsion to the target. During the inspections, units are required to demonstrate realistically each of the technical operations they must perform on nuclear weapons in order to accomplish their mission. As might be expected, emphasis is placed on safety to assure that all procedures and precautions which are required for safety are observed. On security, to ensure that nuclear weapons are provided with maximum protection. And on reliability, to ensure that all technical operations are performed strictly in accordance with the procedures prescribed in special weapons publications. Let's look in on this TPI and see how it goes.
Operate the on-off switch to on. AC power and DC power lamps light. Step 01 appears on a step number lamp. And test plug indicator light.
Check.
Install XM75E1 test plug in J2 of cartridge assembly.
Check.
momentarily to press start button. Test cycle starts. Test plug indicator goes out. Step number lamps indicate step being performed. And cycle stops at step 34. Surface to air plug and arm plug lamps light.
Check.
Hold it right there. Suppose at this point that the power supply cuts off. What would you do?
Well, sir, first I'd turn the tester power switch to the off position. Then when the power comes back on, I'd start the complete test all over again.
Is that right?
Yes, sir. That's the procedure on our checklist.
All right. Carry on.
Remove test plug from J2 of cartridge assembly. Install surface to air plug in J2 and arm plug in J3 of cartridge assembly.
Check.
To press start button momentarily. Test cycle continues. Surface to air and arm plug indicator lamps go out. Cycle stops at 59. Safe plug and surface to air plug indicator lamps light.
Cycle stops at step number 40.
Go ahead, Steve. Push the self-check button.
59.
Do you ordinarily push the self-check button when improper indications appear?
No, sir, we don't, but in this case, we know what the trouble is.
You do?
Yes, sir, the fuse. We've had several of them burn on us lately.
What is your next step?
We're going up to 75.
Mm-hmm.
$75.
Throughout a technical proficiency inspection, the performance of those operations which affect reliability and which are critical to the accomplishment of the unit's mission receives special attention. A deficiency is the failure to perform a prescribed operation or performing it incorrectly. It follows that the evaluation of the unit's ability to perform its nuclear mission is usually determined by the number and significance of the deficiencies observed. A single critical deficiency, one affecting the weapon's reliability, could result in an unsatisfactory rating. In addition to checking the unit's ability to perform technical operations, Inspectors General also inquire into other matters which affect the unit's ability to accomplish technical operations with nuclear weapons. These include such factors as the status of personnel and equipment, adequacy of facilities, the guidance provided by higher echelons of command, and the support provided to the unit by other agencies. When the inspection has been completed, the observations of the inspectors are consolidated, and the inspection team chief determines the unit rating. A rating of satisfactory is awarded if the unit demonstrates adequate standards of proficiency and has the necessary personnel and equipment to perform its mission. A rating of unsatisfactory is awarded only for significant deficiencies affecting the reliability, safety, or security of the weapons and the unit's ability to accomplish its mission. All deficiencies are thoroughly researched and discussed by the actual inspectors who conducted the TPI. Before leaving the unit, the inspection team chief holds a critique to discuss the results of the inspection.
The classification of some of the material to be presented during this critique will be secret restricted data. I will vouch for the security clearances of the inspection team members and request that the unit commander vouch for the clearances of the other personnel present. It will not be necessary for you to take notes, since I have furnished the unit commander with a draft copy of all the observations that were made during the inspection. This critique will consist of a summary of the strong points and areas of weakness observed during the past 3 days, a reading of the deficiencies and factors affecting the technical operations of the unit, and finally, an announcement of the unit rating. First, the strong points. War reserve items were properly secured and maintained. Emergency disarm procedures were performed promptly and efficiently. Safety procedures were properly observed, except for one instance during the assembly operations on the Nike Hercules warhead section. A technician's wrench slipped, striking the mounting plate and destructor lead assembly of the one-point self-destruct system. After the accident, the technician failed to inspect for possible damage to this critical component. But with that single exception, the prescribed safety procedures were followed. Now for the areas of weakness. First, there was evidence of a need for more training in the performance of critical inspections of materiel. For example, during the inspection of the 8-inch atomic projectile, the technician who measured the height of the detent above the reservoir in the dashpot assembly positioned his gauge against the flat surface of the detent. Again, during the inspection of the exterior of the Honest John rocket warhead section, the assembly team failed to reject the item for a gouge in the skin, which could also affect weapon reliability. Next, there was a need for closer follow-up and supervision. For example, the supervisor failed to note that the technician did not inspect the entire surface of the warhead section. In this case, the procedure observed was for the supervisor to accept the report of check as a guarantee that the operation has been performed without an actual verification. Another failure of supervision was observed when the technician performing the cartridge assembly test on the Nike Hercules adaptation kit was directed by the supervisor to push the self-check button when the tester stopped at step 40. The supervisor failed to require the prescribed procedures for the self-test of the T4115 test set upon completion of the cartridge assembly test, and for troubleshooting for defects in the arm plug, surface-to-air plug, and cable assembly. Failure to perform these checks and replace the defective component could result in an unreliable weapon. Now, before reading the specific deficiencies which were found, I want to recall to your attention the unit briefing which preceded the inspection. It was stipulated that your training item would represent war reserve, and that the standards for war reserve weapons would be required during the inspection. Here are the specific deficiencies. First, the technician failed to inspect...
The team chief then reads each of the deficiencies observed by the inspection team and invites observations and questions by unit personnel.
The technical deficiencies. Are there any corrections to the observations or questions on specific deficiencies? Next is the question of the unit rating. In a technical proficiency inspection, only a rating of satisfactory or unsatisfactory is given. Based on the results of our observations, this unit is rated unsatisfactory. This rating is awarded because of 4 technical deficiencies which could affect weapons reliability. First, failure to inspect for possible damage to the Nike Hercules one-point self-destruct system. Second, failure to determine whether the height of the dashpot detent was within acceptable limits. Third, failure to reject the Honest John warhead section for a gouge in the skin. And fourth, failure to replace suspected defective components during test of Nike Hercules cartridge assembly. I'd like to take this opportunity to express our thanks for all courtesies extended during our stay here.
After the inspectors general have returned to their home station, and all references are again researched and verified, a formal report of the inspection is forwarded to the unit for corrective action and report back through command channels, indicating the action taken on each recommendation. The report includes only the significant deficiencies and factors observed during inspection. Because of the importance of nuclear weapons to the accomplishment of the Army's missions and the need for extremely high standards of safety and security, nuclear weapons units receive a significant share of command and staff attention and support. In some instances, commanders responsible for nuclear weapons units may not be fully aware of what they can do to help their units attain the required proficiency. So let us now consider this for a minute. The commander must not wait for nuclear-capable units under his command to fail a TPI before he takes action. Command emphasis should exist months before and not minutes after the inspection. Commanders must place emphasis on the technical training of their units and see that it is adequate, particularly as it pertains to those operations which affect reliability of weapons and accomplishment of unit missions. They do not in all instances need detailed knowledge of atomic weapons, but must be able to evaluate the adequacy of the training on the weapons used by their units. Such knowledge must be regarded as a normal part of their qualifications. They must take an active interest in their nuclear units. The commander's personal interest and concern cannot be overestimated. There are three specific areas which need special command attention and emphasis. First, there is the problem of personnel turbulence. There are always difficulties in obtaining personnel and maintaining their proficiency. But the fact that personnel assigned to nuclear units must be of a high caliber, be school-trained, be carefully screened for stability and security clearance, and must develop a high degree of skill through a unit training program, all this makes the problem unusually difficult. The initial problem of obtaining qualified personnel is further aggravated by attrition and turnover. When a specialist is transferred, there's usually a long delay until a suitable replacement can be obtained. Also, technicians assigned to other duties for extended periods of time soon lose proficiency. The commander can help solve this problem by stabilizing nuclear weapons personnel and keep every man working in his MOS. He should stress the importance of building nuclear units using career soldiers who plan to stay in the Army and thus make maximum use of the technical training which they receive. Another problem which concerns the commander is the result of the rapidity with which nuclear weapons improvements and new developments occur. Each year brings new warheads, new configurations, and new testing and handling equipment. Continuous weapon systems analysis and product improvements generate a continuous flow of new and revised procedures and the related problems of publication changes. If distribution of vital publications is faulty, or if a unit fails to post changes when they are received, or fails to change its operating checklists, the reliability of weapons can be affected. The commander can help solve this problem by assuring that publications are promptly distributed to using personnel. He can stress the importance of prompt follow-up when the index media indicate that changes have been issued, and he can insist on prompt and careful posting of changes. The third problem area concerns the application of acceptance and rejection criteria. It is imperative that nuclear weapons technicians perform precise inspections and apply acceptance and rejection criteria properly. If these precise criteria are not properly applied, defective weapon components may be used, which can result in the assembly of an unreliable weapon. On the other hand, components may be unnecessarily rejected, and this can delay or negate accomplishment of the mission. again, emphasis should be placed by the commander during training on those areas where the faulty application of these criteria could affect weapon reliability or the accomplishment of the mission. Mere ability to cite the criteria is not enough. Technicians must be highly skilled in measuring or otherwise determining that the weapon components are within the tolerances prescribed. For example, the maximum allowable limit for the depth of a scratch on the external ballistic surfaces of the Honest John Adaptation Kit forward of station 13.5 is 2/100ths of an inch. In order to determine the depth of scratches with this precision, technicians must be skilled in the use of a dial indicating depth gauge. The commander can solve this problem by ensuring that his technicians are afforded the opportunity to develop the necessary skills and to practice the proper determination and application of acceptance and rejection criteria. In summary, then, the commander must take an active interest in his nuclear units. He must recognize their problems at depot level or in the field, and have himself briefed regularly on their needs and requirements. He must take time to visit installations and to make himself available to his commanders. The motivation created by the commander's personal interest and concern will assure a high level of technical proficiency. That technical proficiency which is so essential for Army combat readiness with safe and reliable nuclear weapons.